So hello world, this is a video showing the progress I've made on my new project that I started with, which is a Z80 computer made from bare components like these, like here, so all this stuff using to make a computer like this. That's stupid. Why am I doing portrait mode? Okay, so the core is a Z80 CPU. This one here, it's actually it's actually an 8 MHz CPU, but it's running at a rate of 4 MHz by this crystal here. There's nothing there except like crystal, and a connector for the power LED, which is under here, like this power LED from PC. This one. It has currently only 8K of SRAM and a 64K EEPROM, but I'm only using 16K space on the address space is 1616, and those two are both 16 and 16, but not yet inserted. So I have to do, because I want to do banking as well here, so I'm still working on that. It nearly works, so I have to fix some things, but otherwise, yeah, just some reset and a 74HC139. It's just I/O header, like just on a bus. I use it for at the early beginnings to hook up an 7-segment display to read out the address and data bus. And this is just like, for instance, here. Like, what is this? This should be interrupt request and stuff. Just tied to the VCC. That's good. Then we have here the UART, so that's the only thing it has for I/O right now. A 8251 USART. 8251A. Here just a 74LC138 for the I/O address decoding. Max 202 for the RS-232 voltages. This is an RS-232 converter, converter connector from an Asus PC apparently. And these two are actually quite good. I mean, that's pretty cool that I made that work, because the UART needs a clock for the transmit and receive timing. And I only have a 4 MHz crystal, so that's an issue, because if you calculate it for I'm using it now at 4800 baud with an internal 64 clock divider. That means to get the frequency for transmit and receive, we need actually 307.2 kilohertz, but I only have 4 megahertz. So yeah, what the problem? That's a really big problem. But apparently, if you divide 4 megahertz by 13, which is what those two, so this is a 16 counter, BCD counter, and this is just a 32, so 7432 OR gate to do the reset for the counter, and it divides the 4 megahertz by 13, which actually equals about 307.7 instead of 307.2, which is required. So it's actually a bit faster, but it works. We don't see any issues with communications. That's great. So I think that's it for the hardware. So here's my screen. If I open a real term right here. So yeah, we're back for part 2 because my dog was barking. So yeah. So we're here at the power on. So we power it on. If we can get it right here, we power it on. There it is. Computer monitor. So if it focuses, yeah, okay, so what can I do? Well, simple things. Peek, poke. So read from memory, write to memory, and it can receive files from via RS-232, so via serial, and it can execute at a memory location. So if we peek, let's say 5, 4, 3, 2 times 1, which gives me, so 5, 4, 3, 2, 4, 16 bytes. Just random crap. Which is, does not have a pattern. It has a pattern. There is actually a pattern in there. Strange. So we can poke. So actually we can peek as well with P. We can peek with a shorthand notation with 5, 4, 3, 2 times 1, giving the same thing. Then we can actually do a bigger one, so peek 5, 4, 3, 2 times 10 gives me, so it is a pattern. Interesting. Gives me a lot of data. Then we can poke 5, 4, 3, 2, and we poke dead beef, for instance. Or maybe peek 5, 4, 3, 2 again, times 1, and we see dead beef. So that is cool. We can do shorthand notation of poke as well, which is an exclamation mark. 2, 5, 4, 3, 4 then, and that's a byte, yeah, no wait, it's 4 bytes long. So we should actually do 6. It should actually print a backspace, but I don't know why real terms not do the backspace like PuTTY does, but PuTTY cannot do file transfers, which I'm gonna show later. I spoiled it already, nice. So 3, 6, and we do 0, 0, 1, 1, 2, 2, 3, 3. And peek again, 2, 5, 4, 3, 2, 4, 1, see dead beef, 0, 0, 1 there. So nice, yeah, that works. So there's that. Now we have the, what is it? Yeah, so next thing is receive files. So I just compiled the file here, a program that I made, which is a Z80 factorial calculator. So it can calculate factorials. If you do not know what a factorial is, I've Googled it for you. So factorial of 5 is 5 times 4 times 3 times 2 times 1, which is 120. The thing about factorial is that factorial of a low number can get long, like really big. Factorial of 20 is like this thing, which I cannot even pronounce. So, but how do we get it there? Well, we do a receive command to memory location where, actually program in here, which is program load 4400 right here. So we want to receive to 4400 to the program that I just compiled, which is, it says here 398 bytes, which I convert with calculator, which is 18E. So 018E here, and then we send the file, actually just checking if it picks the right file, and then we send the file. Oops, didn't press enter. Well, that's not good. Now I'm pressing enter. I don't want that. I messed up. Whoops. Receive 4400 018E 8E. Ready to receive. Now we can send it. Okay, nice. We peek 2400. Whoops. We peek 4400. 10. And we see the program here in memory, we can actually open XVI32 and open, not from the RAM disk, from my documents, Z80 computer, source, then factorial object we see here, so that it outputs the same data. That's good. Check in, you can check it, but I know it's right. So this here, if we run it now, 4400, see our program factorial, enter an integer number. So if you see, like, the factorial of 24 is, no, the factorial of 4 is 24. Fast, if you run factorial of 00, again, so factorial of, say, 20 is this huge number, which is actually correct, you can check it. So what it actually does is it takes the resolution of 20 digits. So here, if you check it, it reserves space for 20 digits, integer digits. So anything above that will actually not calculate correctly. If we check here to scientific, and we take the factorial of a number that's bigger than 20 digits, for instance 25, actually this number, but it will show up wrong on my result. So we'll run again, 4400, we do 25, actually shows a wrong value. It's actually shorter. How come? Because like 20 digits, if we take here 00, this is 20, 19, 80. So it cuts off leading zeros. That's the way I do my calculation, so it only returns this value. But yeah, I think that's all I have to show right now. The next step of my computer here would be to add, of course, yeah, this is the PIO slot here, so the PIO, I don't really have any use for it now because I have serial to input to the screen, so, but I'm looking at doing removable storage, like either a floppy drive using, so a 3.5 inch floppy drive, or a like IDE connector with a compact flash card, or an IDE hard drive. So that's the next step, which already is difficult. I checked the datasheet of the floppy and that was really hard to understand, so yeah, I'll keep you posted, I hope so. So yeah, that was it. Bye.